In this video, I'm going to show you how to detail a concrete wall in Revit 2024 using the Graitec Advanced PowerPack Detailing plugin. This powerful tool can help you efficiently reinforce your concrete structures. Let's dive right in. In the previous videos, we discussed how to detail rebar on footings, columns, beams and slab with the plugin tools. You can find them in the playlist given in the description below. We can start by first hiding the existing reinforcement in the view. I have modeled the walls with type as concrete wall. We will discuss on how to detail these two walls with the PowerPack plugin. I will drop here, then select Reinforcement Assumptions command. Select the wall to be defined, then hit Finish. We can start by defining the wall web and nodes bars. I will leave as bars under main reinforcement type. For the horizontal bars hook angle, I will set at 90. I will check impose vertical bar spacing, then give a value of 250. I will also check horizontal spacing, then give a value of 250. You can select your preferred bar size for the horizontal and vertical by checking on these two boxes here, then set the type. I will set the horizontal bars as the bars closer to wall face. For the transverse rebar type, I will leave as none. You can choose to adjust bending diameter for the transverse bars if you have transverse type selected from here. In nodes reinforcement type, I will set to extend horizontal bars. Make sure to define these settings according to your design requirements. I will set to none for the nodes transverse type. Then in spacing, I will type 150 for the minimum spacing. I will leave the maximum spacing at 300. You can also give the minimum and maximum diameter for the bars for your design from here. I will enable the last two options, then proceed to slab starter bars. Top and bottom starter bar settings can be modified from this dialog. I will not provide starter bars for my design. In U-shaped edge bars, I will provide both left and right bars, then set the rebar type to Y12. I will set these bars to have same spacing as main horizontal bars. I will leave the length as 600 defined from 50 multiplied by my bar type, which is Y12. I will define the vertical bars as 2, which can be seen from the preview above, and the type as Y12 for the vertical constructive bars. We can proceed to last level linkage. I will enable generate vertical linkage to have the bars provided, which can be edited as you will see. Enable current level option, then give the minimum diameter from the type drop list. In fabrics, you can set the mesh settings if you selected fabrics as the main reinforcement type. We can proceed to edit the horizontal linkage bars. Here, I will enable generate horizontal linkage option, then proceed to opening bars. For walls with openings, the lintel bars can be modified from this area. You can watch the next video on walls to see how the lintel is generated by this plugin. In constraints, you can edit the number of bars for both vertical and horizontal bars according to your wall width by editing the condition values for the bars. I will click on OK to finish defining the reinforcement assumptions for the wall. We can detail the wall rebars by using the constructive dispositions command to have the rebars generated in the model. I will select the command, then pick the defined wall and hit Finish. I will close the design status dialog. The plugin has automatically placed rebar within the wall as defined from the reinforcement assumptions. If I rotate then zoom to a wall edge, hooks have been added as defined earlier. Vertical linkage bars have been generated as you can see at the edges. I will set my view to front, then zoom to the bars. The last bars have been generated as linkage at both ends of the wall. The middle bars have been generated as the main bars and all the bars cut off at the slab. I will go to wall 1 3D view to show you the other rebar details. In this view, you can see how the wall rebars have been integrated within the model. We are going to learn how to edit the generated reinforcement using the plugin commands, like how to move these horizontal bars to the column rebars and also how to adjust the length and shape of the vertical bars. I will go to a section view to view the detailing in section before we can start to edit the generated reinforcement. The bars have been cut at the slab top edge at the bottom. At the top, The bars extend above the beam as you can see. With my design, I will explain how to get the correct values manually for the rebar offsets. I will extend the vertical bars up to the bottom beam rebars, then define a hook length and angle at the bottom and top of the wall rebar. Using this plugin, you can easily edit the rebar while in 3D view or any view within the model. I will open another section view before we can start to edit the wall rebars. I will select this section view, right-click, then hide in view by element. We need to determine the distance of the bottom vertical wall rebar up to the bottom beam rebar. We also need to know the same value for the top bars. To edit the wall rebars, drop here, then select main bars command, then select the wall. We can start by editing the vertical bars parameter values. Here, we can set the required bottom and left offset values with preview above for the location. The top and right offsets can be edited from here. I will start by setting my bottom and top offsets to 0. This will help you to determine the final offset values in section view. I will press OK to continue. The rebars have been updated in the model as you can see. At the bottom, the vertical rebars now cut off at the slab lower face. I will sketch a detail line from this edge line up to the bottom beam rebars. Type DL for detail line, then I will start from this line here up to this bottom rebar here. Press escape to exit the command. My distance is at 260. The final distance will be 260 minus 6, which is half the rebar diameter. This will give us an offset value of minus 254, which I will be using as the bottom offset value for the vertical bars. I will copy this value, then delete the detail line. We can select main bars to edit the vertical bars, then select the wall to edit the reinforcement. In vertical bars, we can edit the bottom offset to the defined value of minus 254. Press OK to update the model. If I zoom to the wall area, then select the main vertical bars. They now end at the bottom beam. I will switch to section 6 view to continue to define the bars further. Half the rebar diameter value was subtracted from the offset because we'll be adding hooks at the end. Click on an empty region to deselect the bars. Select main bars, then select the wall. I will set the bottom hook angle to 90, then give a hook length of 120. Press OK to update. If I zoom to the rebars, hooks have been applied with our given parameters and the wall rebars have been placed above the beam rebars. Rebars generated with the plugin are constrained as specified in the main bars parameters. With the bottom vertical bars adjusted, we can proceed to define the top side. Here, I will find the required distance by typing DL for detail line, then start from this line here up to the top beam rebar face. I will draw another line from this rebar endpoint going this way. I will select this line, then snap it to the horizontal line. We have a required offset value of 310 as seen. The final offset will be 310 minus half the rebar diameter value. I will copy this value, then delete the detail lines. I will delete the other detail line too. We can go to main bars to edit the bars, then select the wall. While still at the vertical bars, I will set the top offset to minus 304 as defined earlier. I will set the hook angle to 90, hook length to 120, then press OK to update the reinforcement. Hooks have been added at the top and the bars do not interfere with the beam rebar as seen. The hook length can be adjusted in the main bars command to have them extend to the beam stirrup. I will go to 3D view to view the wall reinforcement. The main vertical bars have been placed within the model as specified first from the assumptions, then by editing in the main bars command. At the wall edges, notice how the bars have not been edited. To edit the wall linkage rebars, drop at main bars, then select the wall linkage bars command here. Select the wall to edit the linkage bars. We can start by defining the vertical left edge parameters. I will set the bottom offset at minus 254, then set the hook angle to 90 and 120 as the hook length. I will go to the vertical right edge settings, then set my bottom offset to -254. I will also adjust my hook angle to 90 and hook length to 120, then press OK to update the rebars in the model. You can see how the wall linkage bars have been generated at the edges. We can still edit the hook length to lengthen the leg value for the bars. I will repeat the previous command by right-clicking, then select Repeat Linkage Bars. I will set the bottom hook length to 350 at both the vertical right and left edge hook length value. Then press OK to update. The linkage bars leg have increased as defined in the hook length. Hooks have been adjusted at both the bottom left and right bars. I will go to Section 5 View, then select the main vertical rebar set. In Properties, I will scroll down to Dimensions, then note the A value of the main bars. I will use this value to calculate my linkage bar top offset. That is the value from this endpoint up to the top endpoint here. With that, we can proceed to edit the linkage bar's top offset. I will right-click, select Repeat, then select the wall. I will type 3370 as the top offset value, then press OK. If I zoom at the rebar, the bar extends above the beam. I will type DL for detail line, then start my line from this endpoint here, go this way up to somewhere here, then drop to the top beam rebar. I will press Escape to exit, then select this line and recall the value of 260. I will highlight on these two lines, then hit Delete. We can go to the wall linkage to update the value of the top offset, then select the wall to edit. Our top offset is now this -260, which is 3110. We can set the hook angle to 90, then give a hook length of 120. I will go to vertical right edge, then define the top offset as 3110. We can set the hook angle to 90, then give a hook length of 120. If we zoom to the beam region, notice how the linkage bars has a 90 degrees hook and the orientation from the main bars. We can view the bars in 3D view. Both the left and right edges have been updated as edited in the wall linkage bars command. We can now discuss how to edit the horizontal bars. To get the required offset value in section view, you can first select and determine the bar endpoint. If you want to extend the horizontal bars to the column rebar, you need to determine the value from the column edge by typing DL for detail line. I will start here, up to the vertical column rebar here. We need to offset the left endpoint to a distance of 220 minus half the rebar diameter. I will confirm the right offset value in the other side of the wall. I will start from the column endpoint up to this column rebar. The value is the same as the left offset at 220. We can edit the horizontal bars by selecting the main bars command, then select the wall. Select horizontal bars from here, then start by editing the left offset to -214 as earlier discussed. I will also set the right offset to -214, then press OK to update the model. If we zoom to the column rebar, the wall horizontal rebars are now constrained to them as seen. In the 3D view, you can see how the wall rebars are now detailed at the column. The horizontal wall rebars have been linked to the column as required. In this other 3D view, all rebars are visible and you can see how the rebars have been generated using this powerful plugin. You can watch the previous videos to learn how to use the plugin to detail rebars on footings, columns, beams and slab. At this other wall end, the horizontal wall bars have been extended to the exterior column rebar too. At the top, you can see how the bars have been integrated with the beam. You can modify the rebar properties such as length, cover, hooks and bends by using the main bars command. I can rotate to the other wall face, then explain how to add U-bars to the wall edge. U-bars can be used to strengthen the joint at the wall with the column. We can add these bars by dropping at main bars, select wall linkage bars, then select the wall to modify. Select U-shaped edge, then check both left and right edges to detail the bars to the model. In quantity, I will set to 11, then click outside. You can set the length from here. The rebar type can be selected from here. Set the start and end offset to a value that will make the spacing value equals or almost the same as the horizontal rebar spacing. I will use 70 as my offset value both at the start and end. The U-shaped spacing is at 251, which is almost at 250. I will press OK to generate the bars. U-shaped bars have been generated with the given parameter values. The bars have been detailed above the horizontal wall bars without interference. The plugin details the reinforcement according to the industry standards. I can pan to the other wall end to view the bars. If you select on any generated rebar, you still have the basic rebar commands available within Revit. I can select on these bars, then go to rebar set and edit the spacing value or edit constraints. To ensure our detailing is accurate, we need to generate and review reinforcement schedules. You can use Revit scheduling tools to create these schedules. Check that all bars are correctly placed and match your design assumptions. And that is how you can detail a solid concrete wall in Revit 2024 using the Graitec Advanced PowerPack Detailing plugin. I hope you found this tutorial helpful. If you have any questions or need further clarification, feel free to leave a comment below. Don't forget to like, share and subscribe for more tutorials. Thanks for watching. See you in the next video.